Welcome to a course on calculus. In this lecture, we are going to continue with what we have seen in the previous lecture. That is, we are going to work out few problems on discontinuity of first kind. Let us have a quick recap of what discontinuities of first kind. That is, we say a function is continuous if limit x approaches c, f of x is same as that of f of c. Right? And when the limit exists and they are not equal, then we say that is a function is not being continuous at a particular point. We say the function has a discontinuity, right? When this is the case, we say the function has a removable discontinuity at x is c, right? And next the case is when this limit does not exist. Okay, this limit does not exist in the sense we may have limit x approaches c plus this exists, and similarly limit x approaches c minus f of x. These two exist and they are not equal. In this case also we say that the limit does not exist. Okay, if these two exist and they are not equal, then we say that the function has a discontinuity of first kind. Okay, the discontinuity of first kind may further be classified into right discontinuous or discontinuous from the right or discontinuous from the left. How are we checking it? Suppose limit x approaches c plus f of x exists and is same as that of f of c, but this is not same as that of x minus c plus. If this is the case, we say that it is right continuous. Okay, because of this plus sign, it is right continuous. When it is right continuous, it means discontinuous from left. Okay, and the next case is when limit x approaches c minus f of x exists and is same as that of f of c, then we say that it is discontinuous from right. Okay, and in the previous lecture we have seen examples for these two cases. Then but these two may not be the case. That is, your limit x approaches c plus f of x is not same as f of c, and similarly when limit x approaches c minus f of x, this is also not same as f of c, and of course these two are not equal. Okay, if it is the case, okay, this is the main thing. With this, additionally we are imposing these conditions and we are giving another names. Okay, now we are going to this kind of one. We say that it is discontinuous both from right as well as from left. In this example, let us see what happens. Okay, here you may see that the function is changing its behavior when x value is 5. Now we will have to evaluate the limit at x is equals 5. Okay, what is limit x approaches 5 plus of f of x? It is limit h approaches 0 f of 5 plus h. 5 plus h in the sense x, this means what? It is bigger than 5. Okay, so this comes into this category. So in the place of x we will substitute 5 plus h. So it is 5 plus h whole square plus 25 times of 5 plus h, and you will have to take what? H as 0 in this. Since we don't have any denominator, but that is black hole scenario things. Divide by 0 or going to infinity is not happening when your h is 0. So we evaluate this, we get what? 25 plus 125, it is 150. Right? And what is limit x approaches 5 minus of f of x? It is limit h approaches 0 f of 5 minus h. This is what? This is 5 minus h plus 5 at h is 0, so you are getting 10. Okay, here what is your f of 5? F of 5 from the definition of a function is 5 to the power 5 to the power 5. Okay, this value is not equal to f of 5, and similarly this is also not equal to f of 5. Hence this function f has a discontinuity of first kind at x is 5. Okay, if in the option, suppose if this question is asked in MCQ, then if you have the option f has a discontinuity of first kind at x is 5, this is fine. Suppose continuous from the left, continuous from the right, if these kind of things are given at x is 5, it is discontinuous from both the sides. That is, it is not continuous from both the sides. Okay, so this is an example of this case, right? And let us see one more example. Let us consider f of x to be ceil of x upon pi. Okay, we will have to find out the points at which the function fails to be continuous. That is, we will have to find out the points at which it has a discontinuity. Okay, so let us transform this function. Since x is a variable and pi is a constant, we may take x upon pi as t. Okay, therefore your function becomes f of t is equal to ceil of t, right? Okay, this we know that this function has a discontinuity at all the points in the set of integers. So f of t has what? Discontinuity of first kind at all integers. We may say it as t belongs to z, right? So in this case we have the discontinuity. What is t? It is x upon pi belongs to z. This has to be the case because this function is defined in the set of real numbers to real numbers. Just for the convenience purpose, we have transformed like this, and we found that when t is a member of z, we have discontinuity of first kind that we have proved in the previous lecture itself, right? So this is the case. If this is the case, we may write this x as pi z, which means what? All multiples of pi. Okay, be it a positive multiple or a negative multiple, at all multiples of pi, which is a, we know that pi is a irrational quantity, right? So at irrational values of this form, we have the function being discontinuous at, okay, function has a discontinuity of first kind, right? So in the upcoming lecture, we are going to see about the discontinuity of second kind. Thank you for watching.